Okay, so now we're going to take a look at how we make some basic measurements and how that ties into this whole idea of significant figures, which we're going to talk a lot about in the subsequent weeks. And then you'll also get a lot of practice with making measurements when we get to lab. But for right now, I will talk just briefly about some basic measurements and how we use the instrument that we're provided with to make proper measurements. So let's say we have this stick, this black stick here, and we're going to measure the length of the stick using the blue ruler on top. And what we can see is that this ruler is calibrated in meters, first of all, and we have some graduations on that ruler. So there's our 0 here on one side, and then it goes up 1 meter, 2 meters, 3 meters, 4 meters, 5 meters, and 6 meters. So here what we can see is that the smallest increment or the smallest graduation that we have is 1 meter, right? So the amount between one tick mark and the next one closest to it is 1 meter. So if we were to measure the length of the stick, what we can say is, without a doubt, that the stick is more than 3, but it's less than 4 meters. So we know that it has to be 3 point something meters, and an abbreviation for meters there is M. We'll talk about metric units next week, but for right now, let's just take a look at this. So we know for a fact that it's more than 3, but it's less than 4. So it's 3 point something. Now you get to estimate, because you don't have any other smaller guidelines or increments between the 3 and the 4. So you get to estimate how much between 3 and 4 it is. And your estimation needs to be reasonable, right? So if you think about between the 3 and the 4, this doesn't quite look like halfway. So halfway would be 0.5. So maybe a little bit less than halfway. So we can say 3.4 meters. And this last digit here, that's what we're estimating. So that's our estimated digit, which means if we're estimating it, that it has to be uncertain, right? We're not absolutely sure about that because we don't have any smaller graduation lines. So with this particular ruler on top, we can estimate to the 10th place. So we can say the uncertainty there is plus or minus 0.1 meter. So that means somebody else making this measurement could perhaps say it's 3.3 meters, right? Again, where they're estimating that 10th place. What you wouldn't want to say though, well, because you're going to be making up data, if you do it this way, you wouldn't want to say 3.45, for example. You wouldn't want to introduce another decimal point, because what this implies is that you are certain about the 3 and the 4. Well, we just said that you cannot be certain about the 4, so you can't have 2 decimal places, right? You can only have 1 decimal place. That's why your uncertainty here is plus or minus 0.1 meter. So we represent this uncertainty with a plus or minus value. Right? And that's the best that we can do with that blue ruler. So let's say instead we were to use a different ruler to measure the length of that stick. And we're using the red ruler now. We're going to zoom in here. And what we can see if we use this ruler, now we actually have smaller graduation lines or closer graduation lines. Here, the smallest increment is not 1 meter, because yes, we have, for example, going to the 3 to the 4, there is 1 meter there, but we actually have smaller graduations between them. And we actually have 10 equal spaces between these tick marks. So each of these lines here would represent 0.1. So this would be 3.1, this would be 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, and then 3.9, and then we get to our 4, right? So here, the smallest increment is actually 0.1 meters, or 1/10 of a meter. So if I were to make a measurement using this red ruler, and I see where that ends up, well, now I can see with certainty that it is the length of the red, or the stick here, is between, it's more than 3.4, but it's less than 3.5. So we know then that it has to be 3.4 something meters. So now we can estimate to the 100th place how much between 3.4 and 3.5 it is. Well, it doesn't quite look like it's halfway. So it's not 3.45, maybe it's 3.44 meters. So in this ruler, we can now estimate to the 100th place. So that's your estimated or your uncertain digit. Somebody else making this measurement may think that it's 3.43. Again, the last digit there is uncertain because we are certain, we're absolutely sure about the 3 and the 4. So the point here is, depending on the instrument that you're using, that will dictate how uncertain your measurement is going to be. Now, in both of these measurements, the one above in blue, the one in the red, in both of these measurements, the last digit is our uncertain digit, right? So the uncertain or the estimated digit in any measurement is always the last one. Okay, so every single measurement will have some degree of uncertainty associated with it, and that is dictated by that instrument, and specifically the graduations that we see on that particular instrument. So for example, if I, let's say, had a slightly different piece of stick that I was measuring the length of, so let's say I had this purple stick here above, and it went right up to the 3. Okay, so if I see where it lines up with this blue ruler, I see that it lines up exactly at 3. How would we record that measurement? Well, we know that it's 3, and if we think that it's exactly on 3, we have to say 3.0, right? Again, we're estimating it to be exactly on the 3, and then meters would be our unit. Now, the reason why is because we just established using this blue ruler, we can estimate to the 10th place. So we need to estimate to the 10th place with any measurement using this blue ruler. So if we think that it's exactly on 3, we can say 3.0, not 3.00. Now we're making up this last digit. And you can't do that in science, right? You can't make up stuff. You can only use the instrument that we have to guide us in those measurements. So that's something you want to keep in mind when we start making and reporting measurements. We're really limited by the instrument that we have. Okay, the smaller the graduation lines that are present, the more accurate we can be in that measurement. The more spread out they are, the less accurate we can be in those measurements. That applies not only to measuring things like length, but also, for example, to measuring things like volumes. So when we eventually get to lab and we start measuring volumes of liquids or solutions, we may use a volume measuring device like something known as a graduated cylinder. Okay, this is used to measure volumes in the laboratory. And you can think about the graduation lines as being very similar to the ruler, except instead of being horizontal, they're now vertical, and they just measure volume instead of length. So a graduated cylinder can look something like this. So it's cylindrical, first of all, and then there's a bottom to it because it needs to hold a liquid. And let's say our graduations go up like this. So let's say this is, I'm just gonna zoom in on one part. Let's say this is 20, and then this is 30 up here, and then between the 20 and the 30, we have 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. So each of these increments here represents 1 milliliter, and this is in mils or milliliters as a unit of volume. We'll talk more about metric units a little bit later on. So here, my smallest increment, even though there aren't any numbers, next to these small increments, you need to realize that this goes up by 1. So this would be 21, 22, 23, 24, 25, 26, 27, 28, 29, and then 30. So if I put some liquid in here, like some water, for example, when you put water in a cylindrical device, it adopts a very characteristic shape. It kind of looks like a smiley face, like this, for example. And that's known as a meniscus. Okay, and for a water meniscus, what we read is we read the bottom of that meniscus. Okay, so you want to get that at eye level, assuming this is your eye. Okay, we're going to read the bottom. Okay, so applying the same rule that we saw before, and using the ruler, we know that this volume is between 26 and 27. Right, so we know that it's 26. It's more than 26, but less than 27. So it's 26 point something. And then milliliters would be our unit. So how much between 26 and 27 it is? Well, zooming in here, it kind of looks like it's almost exactly in the middle. So here we can say 26.5 milliliters. Or again, this last digit is your estimated digit, okay, or your uncertain digit. And there's only one of those. There should only be one of those uncertain digits in your measurements, and it's always the last one, because we are sure about the 26, right? So our uncertainty here then, somebody else making that measurement may think that it's maybe 26.6 milliliters. So the uncertainty would be plus or minus that 10th place, so plus or minus 0.1 milliliters, right? So this is where, this place is where the volume can vary depending on who is making that measurement. Okay, this is the general way that you want to approach making measurements, whether it's making volume measurements, whether it's making length measurements or any other type of measurement. It all is dictated by the instrument that you are using.